Hi folks, it's Brian Gregg, back with another screencast here, and picking up where we left off on talking about Phaser.js. We're talking about game development and how to build a sprite-based game using the Phaser.js framework. If you haven't checked out the first video, I highly recommend you take a look at that. We go through some of the basics of the program structure, and today we're going to be looking at interactivity. And obviously, what's a game without interactivity? So what we're going to be looking at is animating our sprites, moving our sprites, handling input, and the game loop. And we're actually going to do this with a surprisingly small amount of code because Phaser does a pretty good job of handling a lot of this for us. So in the last screencast, we worked on adding a sprite to our canvas. And if you remember, we're working with an HTML5 canvas here to present our game so that it'll be cross-platform compatible and so that it can be accessed on different devices and in different browsers. And what we've done here, just a couple of quick notes about some of the changes that I made. One is for the title.js. I commented most of this out because we're going to be doing a lot of refreshing, and I don't want to have to click through that title screen every time. So I've commented out the title piece, and I'm just going from the title state directly into the game state. And the game.js here is where, the play.js is where a lot of the action is taking place here. And if you remember, when we set up the play state, what we did was we created an object, and it had a create and an update function. And within the create function, we were creating a player object. And I've actually moved that outside of the create function and into the object itself so that we can reference it both in the create and the update functions. The create function is where we're going to do a lot of our initial setup, like adding in physics and setting our initial sprites on the page. And then the update is where our game loop is going to take place. So obviously, anything that we create in the create function, we're going to want that available to us in the update function. And there's a couple of different ways that we can do that, but we'll do that by just making the player an object of the play state, and then I set a variable of self equal to this, and this way we can reference the self.player throughout the application. This is going to help us if we have to, once we get a little bit further along and we start making some more complex animations and we have to worry about variable scope. I'm just preparing us for that. So we set a variable of self equal to this, and we now, anytime we're referencing the player, we are going to reference self.player. If you remember, we added in the sprite to the page using the character PNG file, which I have open over here. Just another quick note, if you were watching my earlier videos, I was using Sublime Text. I've actually made the move over to Atom. Great piece of software if you're looking for an editor. I've used it before in the past and I wasn't too impressed by it, but taking another look at it now, it's a fantastic editor. I highly recommend it. And since I've realized this, it actually does a pretty good job of handling opening up PNG files natively. So really cool looking, really slick way to work with your different assets in an environment like this. Okay, so back to our play.js. So we're adding in our sprite. We're selecting it from characters. We're giving it a position of 300 and 200. and we're setting the frame of the player to 0, which is giving him a this standing frame, and we're anchoring him to 0.5 and 1. And the reason why we do that is basically so it will, whatever x and y coordinates we give to him will be right down the center here. So if we were to set it to 0 and 1, the xy coordinates would be down by his foot over here. If we were to set it to 1 and 1, it would be down by his other foot over here. So by setting it to 0.5 and 1, it's going to anchor him right in the middle here. So with that, we now have a character on the screen, but he's fairly static. So he's completely static. So what we want to do is we want to animate him. And the way we're going to do that is we're going to use Phaser's animation object within the sprite class. And we are going to make a call out to the add function. So obviously when we create a sprite in Phaser, what we're doing is we're creating an instance of a sprite that uses the prototype of the sprite object in Phaser, which is going to inherit certain functions. And one of those functions is, one of those characteristics is animations, and one of the functions associated with animations is add. And this is going to allow us to add an animation, provide it with a name, which can then be referenced later, and then it's going to contain an array, and this array is going to represent each of the frames of the animation, and then a speed. This is how fast the animation is going to go from one frame to another. Once we have added in that animation, then if we were to actually play that animation in the create function here, it really wouldn't do much because it would run the animation once and then it would complete. But what we want to do is we want to constantly run this animation over and over again. So we're going to actually add it into the game loop here. So the update function is where we actually run our game loop. This is where we're going to be redrawing the canvas after every frame. So again, we are going to make a reference to this and call it self, and then we are going to add in an animation. We'll be referencing the self.player, the animations characteristic, and then we'll be calling the play function, and we'll be referencing the name of the animation that we set back in the earlier part of the program here. So with that, let's refresh this page, and you can see our character has kind of like a breathing animation. And we can play around with this a little bit. So if we were to, say, change this to 10, actually it speeds it up. So we could see that he's, looks like he's breathing a little bit heavier. And if we wanted to, we can use some of these things within the program to control the way things look. So say, for instance, if your character was getting tired, or if your character's adrenaline was up, you might want to adjust the duration of the animation. Another thing is if we wanted to, so we're using these 2 frames of animation here, so these first 2. Let's say we wanted to have him draw his gun. We may take these 2 frames and use them. So let's those would be frames 2 and 3. And let's move this back down to 4. Yeah. And now he's got his gun drawn. I think there was another one here where he had a knife drawn. That's 2, 4, 6, 8, All right, 9 and 10. So let's, actually I think it's at 10, 11. No, actually that was the bazooka one that I grabbed. All right, let's 8 and 9. So you could see when you're working with there's this knife animation. So you can see that when you're working with a sprite map, you have the ability to pull in these different, you load the one asset, and then once you have that asset loaded, you can slice it up any way you want to make different animations. So if you have a character that's going to pick up different weapons along the way, or maybe he's going to change uniforms, or you want to have different enemies on the screen, you can just use the one asset and then slice it up for exactly the animations or characters that are required. All right, I like him with his knife there, so we're going to leave him as is. And next thing I want to do is I want to talk a little bit about the physics. So if you remember in the did we do that? I think we pulled that into boot. Yeah. So in our boot.js, we actually loaded a physics system here. And the reason why we load this physics system in is because once you make a character interactive, you're going to want to have the ability to change their velocity. So if you were making a car racing game and you had, let's say, the A key was going to be to accelerate, you might hold down the A key. You want to increase that velocity, the X and Y velocity, to make the car go in the direction that you want. And that's a pretty basic example, but in most games where you're going to have a character that's moving on the screen, you're going to want to be able to control their velocity in the X and Y directions. So by adding in this physics engine, we're enabling our character to move on the screen. So here we have the reference to our game and then a reference to the physics engine. We enable the physics engine for our player, and we're actually going to be using arcade physics. So Phaser has a couple of different types of physics engines that come built in, but we're going to be looking at the arcade physics engine. And we'll take a look at how we can use that in a little bit. And then the last thing that we want to do here is we want to make sure that we are capturing user input. So it's a couple of different ways that we can capture user input. We can have keystrokes, we can have mouse clicks. The way that I like to handle any type of mouse input, so we're going to be using mouse input for moving our character on the screen. The reason why is because I want to make something that's cross-platform compatible. So we want to have something that's going to be able to run on a tablet or a phone or a laptop. And, obviously keystrokes are an easy way to handle mouse input for a game. An easy way to handle input for a game, but they're not going to be cross-browser and cross-platform compatible. So we're actually going to be using the active pointer, and the active pointer is actually going to allow us to handle a mouse click or a touch input depending on the device that's being used. So generally when I'm trying to make games that are cross-platform compatible, I'm going to want to use the active pointer so that we ensure that input can be handled on a variety of different devices. And then the last thing that we want to do here is in our game loop, we're actually going to be waiting for input. So the way that we do that is using our active pointer. We are going to check for a Boolean value of is down. So every time the screen is being redrawn, for every step in the game loop, the the game is going to be listening for our active pointer because we've turned that on. And as soon as you you press down on the mouse or you tap on the screen, it is going to trigger an event, and that event is then going to set the coordinates of the players, the X coordinate and the Y coordinate, to the X and Y coordinates of the game input. So let's save this and refresh. So now anytime I click anywhere on the screen, the character is going to be redrawn in the X and Y coordinates. And if you remember up top here where I set the anchor to 0.5, you'll notice that when I click, the X and Y coordinates of my player are at the middle bottom of the sprite. So if I was to change this to 0 and then refresh the screen, you'll see that it's now at the top of the sprite. Same thing with the 0.5. If I change that to 1, now it's to the left of the sprite. So you can play around with that, but I find that setting it to 0.5 and 1 usually gives you kind of what the expected response would be. And if you notice, when I actually hold this down, right now I'm holding the mouse down, I can kind of drag my character around the screen and leave him wherever I want him. And then last but not least, so that's one way of handling input. Another way of handling input would be to change the velocity of our character. So since we added in the physics engine, we actually have the ability to change our players. In addition to changing their X and Y coordinates, we can change their velocity. So let's just say, for instance, we wanted to have a character that was going to move left or right on the screen depending on where we clicked. One thing that we could do is we could say if self.playerX is less than game input.x, self.player.body.velocity.x equals -10, else if, just copy this, is greater than game input.x, equals +10. Now, let's see if I got that right. Oh, I got it backwards, hold on. Okay, so now what you see happening here is we're actually, again, on every iteration of the game loop, we are checking to see if the active pointer is down. If the active pointer is down, then we can check to see if the X coordinates of our player are less than the X coordinates of our mouse input. So if our player, his X coordinates right now, let's say, are 100, and if we click over here, our game input .x would be 10. So the player's X coordinates would actually be greater than the game input. So here we would set the velocity of X to -10 because we want him to move to the left of the screen. If we clicked over here, the player's X coordinates would be less than the game input X coordinates, so we'd want it to be a positive value. So that's why when we click to the right of the player, his velocity is going to start to increase to move him towards where we clicked. And if we click to the left of him, it's going to move him to the left. And then we can kind of play around with this if we want and set bounds so that when he reaches that particular x coordinate that we clicked on, he's going to stop. If there's another character on the screen, we can have collision detection to check to see if he hits them. And we can actually, if we wanted to play around with this a little bit, we wanted to actually accelerate the character. So instead of just setting the x velocity equal to 10, we can set it to, we can add 10. This way, when we click, if we, hold on, let me just refresh the screen here. We can continue to accelerate him until he reaches a particular, maybe we can set a threshold for the maximum velocity, but this way, you know, the longer we hold the mouse down, so if we just quickly click on the page, he's going to start moving at a certain velocity, and when we click in the other direction, he's going to slow down until eventually he changes velocity, and if we just hold the button down, he's going to move very fast, and he's eventually going to move off the screen. But we'll be looking at collision detection a little bit later. That's it for today. Hopefully you found this insightful. There's a lot that you can do just with kind of what I've shown here in this small bit of code. I'll put this out on our GitHub so that you can take a look at some of the code for yourself and start playing around with it. So thanks for watching. I hope that you enjoyed this. If you want to reach out to me, Twitter, Ignore Intuition, or add comments to my channel, I'm more than happy to talk about game programming and JavaScript. All right, thanks.